Welcome everyone to Season 1, Episode 1 of Learning Happy Hour. I'm your host here, Ronen in Melbourne today actually. I made a trip out to meet up with a good colleague, a good friend of mine, Mr. Luke Jarman. So
thank you for
welcome.
having me. No, it's great to be here. Thanks for having me, Ronen.
It's hopefully it's going to be a pleasure.
It'll be
We've
fun.
got some interesting stuff to talk about.
We certainly do.
So today what we're going to be covering is an interesting feature in Prisma Access called ADEM. Now, if you've attended some of our training, specifically the EDU 318 class, Prisma Access course, we do touch on it ever so briefly, but personally, actually, I wanted to learn more about it, and Luke here has generously offered to maybe have a quick chat and demo some really cool stuff regarding it and tell us a bit about yourself. So before we get into that, Luke, tell us a bit about yourself. I know we're in Melbourne, but who are you?
Who am I? So yeah, I'm Luke Jarman. As you said, I'm a systems engineer or sales engineer or solutions engineer, depending on how or what nomenclature you use, but I'm based here in Victoria. I have a number of customers across several different verticals in Victoria, along the sort of enterprise size, ranging from retail all the way across to government. And I guess my job is to ensure a customer is satisfied with our solution technically. It meets their business needs as they need it. And that's sort of my role, I guess, in the sales process, if you want to call it that. And that's what I do here in Melbourne, Australia. And I love my job. Problem solving is what I love to do, and that's what I do on a daily basis.
Right.
I get to do it with cool tech too.
How long have you been at Palo specifically?
It's been just over 4 years now, which is actually crazy when I say it out loud. But prior to that, in my past life, I was a network engineer.
Yep.
And I came across to I guess, vendor land, if you want to call it that. And I've loved every bit of it so far. So
interesting you say come across to vendor land. So I've done my rounds around the IT circuit and been focused more on security for as long as I could. But I always imagined that moving to a vendor was like the people I had worked with, not with Palo Alto Networks, but with other vendors. You go to a vendor to retire. It's like, that'll be my last job kind of thing.
The end state, the end goal.
Because you're always worried you're going to become like a one-trick pony. But that's my concern.
I had that concern too. Also coming from, so I was in customer land, I was in partner land or reseller land, and then I came across the vendor land. And I was always sort of hesitant on the sales aspect of the job, but funnily enough, that's the part that I really enjoy a lot of the times the most. The competitive aspect to it, the excitement is part of the part that I really, really like. But yeah, I had those reserves, or I had those concerns too. But I've been here 4 years now, so clearly not an issue.
Well, you beat me. I've only been here for three and a bit now. Yeah,
Make
but
sure
I've been working closely with the company as an instructor for like 10. So
okay, you beat me on that one.
But it's interesting because after joining, even though I was worried about the one-trick pony thing, there's always new tech here. We've got, apart from like the three big branches, we call them Strata, Prisma, Cortex, right? We've got XDR endpoint stuff. We've got XSOAR for SecOps, which is my main focus now. It's really exciting.
It's a fun tool. Yeah,
it's so cool. And then Prisma Access, but the order doesn't really matter. But like, there's a pretty wide gamut.
That is true. And coming from a network engineering background, I didn't really even know security all that well. So that's been a huge learning curve. But as you say, we're pretty lucky in the vendor that we work for is that there's always new stuff coming down the pipe from a product standpoint. Sometimes it's good. It's hard to learn all this stuff. Yeah. Sometimes it's bad. But yeah, it's never, you never get bored here. And customers always have different challenges too. So just on that basis, we're never ever bored. There's always something different, which is part of the reason why it's such a good job.
As an instructor, I'm kind of lucky in that way too.
You have to, and you got to know it because you got to teach people. I just have to sell the dream and walk away. You actually have to know it well enough to. Yeah.
Well, that's why I'm excited about having this conversation with you, which actually segues us nicely into like, what are you going to show us? So teach me some of the cool stuff about ADEM. I know a little. I've dabbled, but like, what kind of scenarios do you see there out in the wild?
So, yeah, I think before we get into the product, I think it's important to understand that the problem that ADEM solves. So if I go back to my network engineering days, my job a lot of the time was, as I called it, defending the wire. In other words, making sure it wasn't the network that was the issue. Because as if you're a network engineer out there and you've felt this before, we are often the default gateway for blame. We have to prove innocence a lot of the time. It's always the network until it's not. And so in that process, I had to learn a lot about things like TCP, the way that the networks work, the way that bandwidth and latency interrelate and how that impacts an application performance. That taught me a lot about networks, and that was a big part of my job back then. However, these days, with things like SASE, the network guys these days don't necessarily have, network guys or girls, sorry, don't necessarily have control over all of the network from where a user is and where their application is. So in a lot of ways, I feel sorry for them because it's sometimes a lot harder now to prove innocence.
Right.
When I compare it back to when I was a network engineer, it was very much a closed loop ecosystem that I had control over almost exclusively from end to end.
Yep.
So if there was a network problem, I could probably find it. I had a packet capture available. I knew that the Wi-Fi was good. I had that end-to-end visibility. These days, again, with users that could be in an airport somewhere, in a hotel, at home, on a bad internet connection, poor Wi-Fi, maybe their device is playing up, the network guy doesn't have those controls anymore. However, they still cop the blame when things go wrong. Right. So a lot of what ADEM aims to solve is just that.
And it does so, from when I talk about it in our class, in the 318 Prisma Access class, it's mainly about visibility, right? Mm-hmm. Being able to quickly identify where potential issues reside and not waste time
trying to troubleshoot.
Yeah.
Doing pings, speed tests, WireShark captures, all that stuff is great. But oftentimes by the time you get to the user's machine, the issue's gone away. So then you're like, okay, well, next time it happens, let me know.
Yeah.
Jump on, the process repeats. And what it ends up with, it's a bad user experience problem. It's for the user themselves trying to do their day job. And it's also bad for the operator, the network engineer, the service desk person that has to try and figure this out, right? It's bad and it's got business impact in multiple ways.
It's frustrating for everyone too.
Yeah.
Which we're going to talk about user experience as well. I've got a few words I want to share there because I have a bit of a background in load balancing. I did a lot of work with F5,
right?
Their LTM space, and some of more security stuff too. But yeah, I want to
dive into that.
Cool stuff. Yeah. What can you?
Back to the network the days of me being a network engineer. I talk like it's a long time ago. It wasn't really that long ago, but thanks to the last few years.
The pre-COVID era.
Yeah, exactly. Thanks to a lot of network transformation, the landscape for the network engineer has changed a lot. But I'm only talking sort of 4 or 5 years ago. But as I mentioned, oftentimes I would be buried in things like WireShark, where if you have a good enough understanding of TCP, there is absolute gold buried within that. And by gold, I mean tools and the ability to shift the blame, hopefully, to someone else. To say, and sometimes it is the network, of course, and no denying that. But if you know enough about TCP and you've got a packet capture, and I was lucky enough to have tools back in our network where I'd always have that availability, you can look into a packet capture and get a lot of really good information to hopefully assign the blame or mean time to innocence, mean time to blame really, really quickly.
Mean time to blame?
Yeah, well, mean time to innocence, mean time to blame, depending. So you're looking at things in 2 different ways, but that's that's what it's all about.
MTTB, right?
Yeah, like as I said, I was defending the wire back then, and that's what my job was. Now, it was always fun. I didn't want to try and make anyone responsible for things, but you wanted to get to the issue or the root cause of the issue quickly because you've got other stuff you need to do.
Yeah.
And there's a user on the other end of this that's having a bad time, so you want to fix that too.
Awesome. Okay. Well, let's jump in. So you've got this background in hardcore TCP dump analysis.
Yep.
Moderate to hardcore.
Yep.
I've dabbled myself, and it's a tool that I think a lot of the viewers here have used or seen might not be hyper confident with because, as you said, there's a treasure trove. There's
so a lot of gold in there, and it applies to firewall things too, TCP and sessions, and that all relates very much to the way that our firewall allows and denies things. It's all, if you've got that foundational knowledge, it really, really helps with things later on down the track. But yeah, as I mentioned, I was often buried in packets, and I'm happy to jump on a whiteboard here to maybe show you what the flow of a standard TCP conversation looks like and what you can just glean very basically, even looking at something like a 3-way handshake.
Let's do it.
All right, cool.
All right, cool. Let's have a look.
So this is just a visual representation, I suppose, of the standard TCP interaction between client and server, or user and application. Same thing, as you can see, as I mentioned, 3-way handshake. We can see the SYN packet from the client telling the server that I want to initiate a connection with you. The server responds to say, yep, I got that, you're good to go. And then we get another acknowledgement back from the client to the server. But even just looking at this, while it doesn't look like doesn't look all that exciting, if we pretend that this kind of y-axis here is time, if we are to measure, say, the difference between when the client sent the first SYN packet and when we got a SYN packet back, this is another way of looking at what we would call round trip time or network time or response time. So straight away looking at this, if I was to look at this and see that it was quite quick and say, I don't know, something around the realm of 30 ms, for example, I would say that's a fairly healthy network, just looking at this, because we can make a fairly safe assumption that the server would have responded to that SYN packet almost instantly. So this packet going back and then another one coming back again is exactly the same as round trip time.
Yeah,
so there, I can get some great information from that.
How long does it take for a packet to get from me to the server that I'm trying to
access?
And
back again. And yeah, back which again. Is exactly the same as doing a ping. However, I would say this is a little bit better than doing a ping because you're actually accessing an application on a port as opposed to a ping. ICMP can often be deprioritized from a networking standpoint or a server standpoint, so it might make things look worse. This is like another way of saying maybe even a TCP ping.
Well, it's closer to production traffic. It's closer to reality.
Exactly.
Anytime you can do a monitor or a test that is
a bit closer.
Yeah, more what a person's actually doing.
Whereas a ping can often be a bit of a red herring sometimes. It might be slow, but it might be because something's deprioritized.
Could go the other way too. You could have someone that's like,
ping's fine.
Ping priority.
Yeah, cause for ping. Yeah, that's interesting. I don't know if some network engineers do that to make themselves look like they're innocent. Maybe not. Ping's fine. Yeah, but looking at this straight away, I've got a pretty good idea that network here seems to be okay.
Yeah, solid. So you're saying like 30 milliseconds?
Oh, I mean, it varies, but if I knew my network well enough, or I knew where the user was, or I knew where the app was, I would expect around 30 here, 100 here, or whatever.
Right.
The next part after the three-way handshake, and a bit of trivia for those that know firewalls well enough at home, you'll notice that a Palo Alto Networks firewall will allow the three-way handshake to occur, and there's a good reason for that, and maybe that's something that someone in the comments can write a response to, and why that actually happens.
Why do we let it through?
Why do we let it through? If there's assuming there's no port-based rule to block it, why do we allow that through? There's a good reason for it.
That's a good question.
It's not someone for the viewers. But after that is then, well, now that I've got this three-way handshake as the client, I want to now, for instance, request a web page of this server. Now, I've simplified this. There's often a lot of more packets that actually occur here. But what usually then happens is a GET request of some description from the client to the server. Now, if we know that round trip time is around the 30 ms mark, we can take another metric or another little line here, and I'll change colors, to see this delta here. Okay, so there's also a time delay aspect to this, right? Where the server, sure, it got the GET request, but there was a delay between when it actually responded to the user. So if we call this server response time, I'll use text box here so I don't have to, SRS or server response time. From this, we can get a pretty good idea of how the server is responding. So if I was to say measure this whole entire arrow, or from start to finish, from here down to here, like this, I could minus round trip time from this and get my server response time, same way. Effectively measuring how long it took the server to respond. So if I was a network engineer, again, back in the day, and I'm talking only 5 years ago or so, if I saw that this was extraordinarily long for whatever reason, that to me is like the smoking gun to say, well, network seems fine here. Your server's taken this long to respond. This is why the user's having a bad time. So
effectively what you're saying is that at this point of the conversation, if we were to packet capture it, we've got all the building blocks that tell us what's actually happened. Yep. How long did the TCP handshake take, which kind of tells me the round trip time. Yeah, network's okay. And then as we go up another layer, if you will.
Into layer 7,
we're looking at the web request, and we can minus the TCP component of it and kind of deduce exactly how long the server takes.
Server response time, server delay, exactly. So yeah, again, if I saw this was large, I would take a screenshot of this, maybe put it in the ticket and put it to the application owner to say, hey, your server's taking a bit longer than normal.
I send you HTTP GET. How come take you?
Yeah, and that's again, I don't want to blame. You don't want to blame people, but that's the smoking gun, right? I felt really good when I got to this point. If I saw something like a SYN packet and then TCP resets at the SYN packet, then I would say, oh, maybe there's a firewall blocking this.
Yeah, okay.
Or the server's not listening on the service, or something like that.
Now this is a simplified example.
Very, very simplified.
And yes. I noticed we haven't put in TLS or SSL handshakes in there, and that would obviously be between the SYN ACK and then the HTTP GET.
It's a necessary part. Before any HTTP occurs, there's a client hello, a server hello. They negotiate, hey, what ciphers are you using? What ciphers have you got? Let's work together on an SSL handshake.
Yeah.
Once that has occurred, then HTTP would follow, which can also introduce delay. If there's something doing SSL decryption and that's taking a long time, you would also see that in a packet capture.
And then you'd add that to your, or you'd subtract TCP plus SSL from the total to give you SRS.
Yes. Now it gets a little harder when things are buried in SSL because I'm not going to see an HTTP GET anymore.
Unless you're decrypting
Yes.
And your packet capture has that, or you're using something like SSL dump.
Depends on the cipher in use. These days with things like Diffie-Hellman, doing what you would call replay, even if you've got the private key, is impossible. But yeah, that's a whole other big topic. But
impossible
right.
is a strong word.
Well, yeah, you can do it, but there's some caveats to it.
Gotcha.
But again, I guess it speaks to the fact that, well, these days most things are SSL. So if I contrast back when I was a network engineer, maybe that wasn't so much the case. These days it is, which means it's even harder for the network engineer of today.
Well, that brings up another point of packet capturing too, because what we're talking about, well, if you're decrypting and if you have a packet capture, me and you are working on the assumption that we have something in stream, like a firewall or some device that is in line and capturing it and decrypting. But if you decrypt on the endpoint,
yes,
and you take the packet capture from the user's machine, then that's no longer a problem, right? Because we're doing the Diffie-Hellman.
Yeah, that is true. If you had the private key, there's a good conversation we had there actually on how you would on what that would look like. But yeah, if you had sufficient access, yes, you could do that. You'd break open the SSL session, and off you go. And that's, I guess, how the firewall or a proxy would do it in a man-in-the-middle sense to make sure there's nothing nasty in that payload. But yeah, it's a good topic, and as I mentioned, having this info is gold. And I can actually show you what it looks like in WireShark too, if you'd like.
Well, let's jump into that then. Yeah, okay. let's take a deep dive. And again, we're not talking about ADEM yet.
No,
this is
just
the manual,
way that,
old school way.
That's right. That we used to have to again prove innocence back in the day, and it was fun. But yeah, there's a bit to learn. But yeah,
let's do it. Yeah, let's jump in. Yeah,
right.
show me the packets.
I've got a packet capture here of a very basic web request, and if we look at the first 3 packets here, you can see that, as I mentioned in my previous diagram, we've got the SYN packet, the SYN ACK packet, and the ACK packet. This is the standard way that TCP starts up a session. And thanks to a really nice column that I've added in WireShark, I can see the time since the previous frame in this TCP stream. So if we take the SYN ACK, which if you look back at my diagram, it's kind of the client side receiving something back from the server.
Yep.
We can see there's a slight delay, which in this case is about 36 milliseconds, which I would be very happy with if I was a network guy. Maybe not if it was the user right next to the app in a data center or something, but that's pretty reasonable. But again, as I mentioned before, this is the gold that is just sort of there in the packets. So that's part 1. Another column that I've added is time since request. And this is specifically looking at how long it took for when the client first requested something from the web server, and then how long it took to respond back. I'm just using some simple filters that are freely available in WireShark, and you can see the first time we get a hit on this or some sort of time delay or time delta, we can see that the server, in this case, has taken 1.9 or basically 2 seconds to respond.
I was going to ask you, is that in seconds?
That is in seconds. So that may be normal for the web app, may not be, but I would say if there was performance problems and the user had called to complain,
bad. What do you mean
2
normal?
seconds is a long time.
Yeah.
Especially, in most web pages, there's probably multiple GET requests, which when you do all that, if you add all that up, that can be quite a significant delay. But again, thanks to the magic of WireShark and some of the fields that I've been able to apply as a column, I can very, very quickly identify that, okay, this is probably a server issue. Right. And again, pump that off to an application team or something.
And close your ticket.
And close, well, not close the ticket, but just go back to doing whatever I was doing and not have to worry about it.
Back to normal life. That's okay, fantastic. And to get that time since request, so there's some clever work in WireShark with filtering.
Yeah, it's just fields. So, like for instance, if we take this TCP packet here, you can see I've clicked on the TCP part or the transmission control aspect.
Yep.
And if I scroll down, oops, sorry, my zoom doesn't work there. You'll see there is a timestamp field, and then one here called time since previous frame in this TCP stream, and that is what I've used to create the column. So I right-click that. I apply it as a column, which I've already done, and then straight away I can start to see that instantly, which is super useful. Same goes for the HTTP component. So if I click on this packet, which is HTTP, and I expand HTTP, you can see, where is it? Time since request, which I've also, as you can see, applied as a column. So I could quickly just sort by that field, and straight away at the top I get the delays, and off I go. So again, absolutely gold. But these days, it's pretty unlikely that you're going to get access to a packet capture this way.
That's fair. But that's still really cool. Like, I didn't know you could do that.
Yeah. WireShark is gold. You could do a whole degree on WireShark if you wanted to. I'd maybe question its validity these days, but it's still very handy to know from a foundational standpoint around how networks work.
So then obviously the segue question is, all right, we can't get these packet captures, and a lot of people don't have that skill set.
That's true.
Like I know why I know WireShark
a little bit,
but not like, I mean, I didn't know that field. That's really cool.
Yeah. Any field you can apply as a column. And it's
that's
useful.
awesome. But I did not know that.
As you say, it's not necessarily logistically possible to do that these days.
We don't have the packet captures and all the, I say all the skill set. Some people do, but often it's not the right people who are trying to.
Well, even if I was in that scenario today, I may have the skill set, but trying to get a packet capture when a user is remotely accessing an application in a data center that I don't own, and trying to do it at the time that the issue is occurring is
unlikely.
Basically impossible.
Yeah, that's too hard.
And you can do things like pings and speed tests, which often come up normal.
Yeah, but it's a totally different stream. Yeah, you can't. All that shows is, does your ISP suck specifically to
this destination, which they've manufactured to be fast because everyone uses speed tests to measure ISP. So it's not really a great test these days.
Gotcha. So then the next the segue is
ADEM.
Well, how do we do it? How do we do it? How do I get this visibility or more? And that's kind of a product or component that we have of.
It's a part of Prisma Access. Yeah. So Prisma Access being one part of our SASE platform, Secure Access Service Edge, Prisma Access being Secure Service Edge. It also is part of SD-WAN as well from our portfolio, which then makes up the entire SASE architecture. Mm-hmm. But it is a product that is there to specifically help with these issues, because these days the amount of variables that I guess can be potentially in play when there is a user experience problem are very large. And they're oftentimes well outside the control of a network engineer or someone in the service desk, yet they cop the blame regardless. So they still have to prove innocence, but doing that is difficult without something like ADEM.
I'm going to challenge you later on, because I have an idea of what you're going to show us. And I want to see if you can, and what you can't glean from this packet capture that you can using something like ADEM.
That is a good challenge. Yeah, the packets don't lie, but it doesn't tell you everything. That's
it's not the whole picture.
Yeah,
it's a good picture.
It is,
but it might not be everything you need. Okay, so let's then
pivot across to ADEM. All right, do you want to take a break?
I was going to say, let's then go grab a coffee.
Okay.
Or even lunch, actually.
It is that time.
Let's have a lunch break, and then
sounds good.
When we get back from lunch, we'll see what the solution is. Yeah, that sounds great.
Sounds good. Let's do it.
I hope you're enjoying this episode of Learning Happy Hour. Thanks for watching. If you're interested in certification or further development and training through Palo Alto Networks, we have a number of instructor-led training courses available. Just visit us at paloaltonetworks.com/services/education, and you'll find ILT, instructor-led training, certification details, and some digital learning too. We are back. Welcome back.
We're back.
That was a good lunch.
By me.
And good coffee too.
Thank you, yeah.
Guys, stick around. Episode 2, we're going to actually talk about a fictitious company called Cafe Coffee Co. Have you heard of them?
No, I haven't.
You haven't?
No.
They were part of the EDU 214 class, a
great
best
course.
Practice course. It was
bloody good course.
Amazing course.
Yeah.
Unfortunately, it's gone.
Oh, okay. Sorry. I filmed that then.
Anyway, so let's continue. So where we leave it off. So we've looked at the raw packet capture. We've used WireShark to poke around and see that there's a delay with the TCP handshakes, if there is one, or looking at that server response time piece, which is really interesting. Let's look at what we can do to see what a user's experience would be.
These days, when we don't have access to packet captures, and as you said, not everyone wants to dive into packets. I'm a packet geek, not everyone else is. So as we mentioned, we do have a part of Prisma Access known as ADEM, or Autonomous Digital Experience Management. I believe that's the acronym.
That sounds right.
Check
we'll
later.
Put it up on screen.
Put up a little text if I get that wrong. But it is there to help with troubleshooting and finding root cause for user experience problems when something goes wrong. Now, I think the best way to show that to you is literally to show you what it's like accessing maybe a private application remotely.
Yep.
Show you what it looks like when it's working well, and then show you what it looks like when it's working badly, just to make things a little bit more real, so you can see for yourself, and we can play out, how the process normally works when we have a user experience problem. So my machine right now is on Prisma Access. I am connected to a Melbourne point of presence, and I have access to 2 private applications running in my AWS data center.
Now, when you say connected to Prisma Access, just to be clear for everyone, that means you've got the Global Protect software installed.
Yes.
And it's effectively doing a client-to-side VPN into Prisma Access.
Yep. So we can do all the inspection goodness as well as the connectivity as well. This is Prisma Access is the highway or the mechanism for me to also get back to private applications and inspect them along the way.
So both for things that we host as well as like SaaS apps or
everything.
Your Gmails, your Office 365.
Zoom, everything is meant to go through Prisma Access. That's by design. There's no split tunneling, which is good, right? From a security standpoint, but also from a performance one too.
Understood.
So I have access to 2 very simple web apps that are hosted in AWS. One of them is called DVWA, which stands for Damn Vulnerable Web Application. And I've got an Atlassian product here known as Bitbucket, which if I'm talking about a fictitious company, the developers that work from home need access to this because it is a code repository and it is critical for them doing their job day to day. So if things go bad with this sort of application, there's a business impact and we need to fix it quickly. So right now, everything is working well. I can click around into my repositories. I'm having no response issues. Everything is okay. Likewise, it's snappy. Likewise with my other application, everything is going well. I can click around.
So all this traffic is going through Prisma Access to your data center.
My AWS instance.
AWS.
Right, which is just a Linux server hosting some Docker containers. But if you translate this with a customer, this could be their physical data center. It could be the public cloud, anywhere where they've got private applications hosted.
Awesome.
And we are accessing this via Prisma Access, as you mentioned, with the Global Protect client.
Yeah,
you can
understood.
see here. Okay, and I'm connected to Melbourne. So everything here is good. But what happens when things go wrong, or what does it look like? So I'm going to add some delay now to this web server so we can get a feel for what it would be like as a user when things start to go wrong. So now the snappiness is gone. I've just clicked the home button. It's taking a little bit longer to load. Now, if I'm a user doing my day-to-day job, this kind of slowness has a material impact to me, and I'm going to start
It would change from a damn vulnerable to a damn frustrating.
That's right, exactly right. And then you have a frustrated user, and being on the other end of that is not necessarily fun.
Right.
Likewise with Bitbucket here too. Again, this is key for this business, this fictitious business.
Yeah, right.
And when things like this are this slow, this slows developers down. That has a material impact on the business.
Yeah, of course.
Things are bad. And this is what it looks like. And then the typical flow from this point is maybe the user would call the service desk.
Right.
The service desk would go, well, where are you working from? Oh, I'm working from home, on my home router, on my home Wi-Fi, on my home internet connection, which you have no control over.
Have you turned it off and on again?
Yeah, if you restarted, what does ping to Google look like? Ping to Google is fine. Yeah. Speed test, again, we can go through that process. And then the service desk person doesn't normally know what to do. They'll go to the network guy, and it's up to the network guy to figure it out. And as I mentioned before, practically speaking, getting a PCAP, that's just not going to happen. So now we can look at, well, how does ADEM solve for this? So as part of the Prisma Access client or Global Protect, ADEM is built into this client, and what it is able to do is do synthetic tests towards your key applications to try and figure out where there might be some problems. Because if you think about all of the different points there are between a user and an application and all the different things that could possibly go wrong, there is a lot. And it's not always network, and it's not always even just server. There's Wi-Fi, which we have no control over now. Someone's home router might have they might be on 2.4 gigahertz. They might be sitting too far from the router. Right. They could have a bad internet connection. They could have battery issues on their machine. If their battery starts going low, oftentimes CPUs will start spinning down, can result in a performance issue. Right. CPU might also be maxed for some reason. All of that can contribute to a user experience problem, but actually getting the visibility of that is almost impossible. Here's a question. Yeah.
You mentioned a lot of different metrics that we're looking at. Mm-hmm. What about RAM usage?
Memory usage is also something that can go bad. If a user, so my boss, I won't say his name, whenever we have a one-on-one and he shares his screen, he's got about 100 different Chrome tabs.
I was about to bring it up. So my wife is a developer.
Right.
And her computer, not just 100 Chrome tabs, she has multiple windows of 100 Chrome tabs. I'm what are you doing?
Yeah, and that fills up, right? And RAM's finite. Once you run that,
Chrome will just
it hogs a lot,
Yeah.
especially when you've got as many tabs open as you and I.
So that's
talked
something
about.
we
can also track. So as part of ADEM, we aren't only tracking network synthetics and things like that. We're also looking at statistics of the machine itself, which again can also contribute to a user experience problem. So let's dive in now to the actual ADEM portal. And here I'm presented with quite a simple screen that shows me the users that are currently connected. I don't have many right now because it's just my lab tenant. But we get some idea of the user experience from a score standpoint. We can see other bits of information around threats and things like that, which is not really what we're talking about today, but of course is relevant. But one particular point that is useful, which is quite simple, you wouldn't think it is that useful, but is quite handy to have straight off the bat, is my internet service provider. So the reason I'm highlighting this is we had a customer leveraging ADEM, and they had about 15 or 20 or so users call up the service desk one day and complain about performance.
Right.
And the administrator that had ADEM was able to very quickly see that all of them were using the same ISP. Now, I'm not going to call out the ISP, but you can see the issue.
It's not this one, obviously.
Well, no, maybe you can blow this one. It wasn't this one, but you can see, right, like that. Then that's not something the service desk person can fix.
Sure.
But they can quickly make the determination.
Right.
Well, okay.
I've got 100 users. 8 of them are complaining, and the common denominator here is
their service provider.
Now,
you can't fix that, but you can say, okay, maybe you can come into the office. May not be practical. Tether to your phone.
That's not a bad one.
There's options, right? They can switch, and that takes the blame away from you, I guess, to use what I was referring to earlier as getting rid of the blame. That right there, I know it's quite simple, but it is actually quite valuable.
That would be near impossible to... What are you going to do? Get everyone to take a packet capture? Both the people who are having troubles and the people who are okay, and then compare the packet capture?
Not going to happen. Or they can go to whatismyip.com. It's a mess. But having this issue, this information up front, might mean you could even get ahead of an issue before that. And someone
nip it in the
calls.
bud.
So this is just the high level, but let's now click into my user to get a little bit more information. Now I need to click up here and click on my experience tab to take a look. And now I'm presented with a little bit more information about my user in particular. I've got a user experience score of 89. Now, this is sort of here's one we prepared earlier kind of scenario where I did this previously, so we can do this live. Right now, everything is actually fine because it hasn't caught up just yet. But if we look a bit further back and I click around here, what I'll do is I'll zoom here so we get a bit more of an understanding of it dropping.
Enhance.
We can see that there was a degradation in user experience. So straight away as a service desk operator or a network guy, I've got a pretty good understanding, okay, something is not right. And what I'm actually tracking here is my Bitbucket application. So I've configured a specific test for this specific application because in my business, Bitbucket is really important to me.
Well, that's similar to what we were saying before, like when you're monitoring, and this comes from my load balancing days, but when you're monitoring something, it's not enough to say, how's my TCP connection? It's not enough to say, how's even web application stuff? This is us testing the specific applications that we have.
That's important to us. And it's not just doing, as I mentioned, synthetic network tests. It also looks at other statistics that might contribute to an issue.
Well, I noticed something hiding down the bottom here, which is the connected SSID.
Yes, so we can even see right now we're on a corporate wireless network. However, you would see a person's home SSID potentially, or I guess one in an airport.
Or if they're switching as well.
Yeah, we would also see that. We would also see if they were disconnecting from Global Protect or Prisma Access as well. All of that stuff is rendered here. But as I mentioned, we're tracking this application. We can see that there's a pretty obvious downward trajectory of performance. Then we can go a little bit further down again and see we're presented with a very simple, I would call it traffic light system of all the different components between that user, or me in this case, and the application. You can see that the device itself, from a CPU, memory standpoint, or battery, is okay. It's green. Wi-Fi seems to be okay. Signal quality, the bandwidth that's there from a receive and a transmit standpoint is okay.
Oh, that's useful, 85%. All right.
Well, yeah, so if someone was sitting far away from their router and it was low, well, that's a pretty obvious. Sit closer to your router. Kind of thing,
Another common one is stop microwaving things while you're...
Yeah, you shouldn't be on your laptop near a microwave. That's probably, or foil, right, if you want to try.
We'll talk about that later.
Yeah, so that's one aspect. Local network. So what's my response time like to my default gateway, which in a home would be their home router, right? If that's slow, well, obviously that's going to impact.
Now, from the packet captures we were looking at earlier, the one you've got highlighted here, that's something we could determine, right?
Well, if there was a round trip time issue, we would see that in packet capture, but we wouldn't necessarily know what was the hop that was responsible for it. Whereas here, we're going a little bit further.
Yeah.
We're seeing, okay, the round trip time's bad, but where along the chain here has it been introduced? Is it the Wi-Fi part? Is it local network? So yeah, that already is more useful than a packet capture.
Yeah,
So I don't want to let go of my WireShark ways. This is better.
So it's impossible to. Is it
Well,
impossible?
you would just see the delay, but you wouldn't know where it was coming from.
Yeah,
maybe you could do trace routes, but again, who's going to be doing that?
No. But you wouldn't if you had a because we're looking at history here. This is
this is back when I first ran this test a
few hours ago.
Yeah.
So even if you had a packet capture from the same period of time, you would not be able to deduce
that it was a local network.
Yeah.
No, I would say, okay, maybe there's a network problem somewhere, but I still wouldn't know.
That's
and then I would have to keep digging, okay, trace route, etc. And that's not really fun for anyone. So local network we're testing. Also local internet, a very common one. Sorry, I'll scroll back up, is obviously how well your local internet link is performing. I mentioned before about an ISP behaving badly for a subset of users. You would see that quite clearly here from a latency, jitter, or loss perspective. Prisma Access itself, so we're obviously in line here. We can also be the potential cause of a performance issue. Hopefully not. Sorry. There's SLAs around us making sure that's not the case, but we are keeping ourselves honest here too. So if we're introducing the issue, well, this might turn up as orange or red.
And if it is orange or red, it still gives the administrator, whoever's troubleshooting,
somewhere to go.
Yeah.
What I do next?
Yeah,
I call my SE and complain. That would be me. and then clearly, finally, the last stage is the application.
Okay, wow.
The server, right? It's quite clearly orange.
Yep.
And we can see that time or TTFB, TTLB, time to first byte, time to last byte, latency, packet loss, jitter, is all very high.
Yep.
Which in this case would be the smoking gun, where I can punt this off to probably the application owner to say, hey, something's wrong with the server. It's not responding properly.
What's interesting is we still have 0% packet loss too.
Yeah, so it's getting there, which you saw, right? I was loading the page, but
it's
it just was super slow.
And
I've artificially introduced this with network latency, which I've done on the server itself, but it presents in exactly the same way if this was for real. But let's go a bit further now and I guess get more back to the TCP mechanics and all those different aspects of a network connection that could be the problem here. So if I click, I've clicked Bitbucket, and we go a bit further down, we've got all sorts of performance metrics around all the flows, all the particular aspects of that connection, from all the way from the DNS lookup, all the way through to the time to first byte, the time that we actually start getting a web page or something that's rendered in the user's machine. And you can see DNS here is good.
Yep.
It's almost nothing, probably because it's cached, but it's working.
But that's an important point too. A lot of people don't realize that sometimes the snappiness of certain web apps, because they obviously rely on DNS to resolve the name of the app to the IP, but sometimes that adds a substantial delay and snappiness too, especially when you have sites that have, I know it's like, well, no, Ronen, we'll just resolve that one site once, and then as you said, it's cached, it's fine.
No problem.
But when you have a site that has many different like iframes and different links.
There's a lot of requests.
Yeah. So there's a lot of independent, well, they're not independent, but subsequent web requests, and they can also be to different domains. And if your personal LDNS or your local DNS
to something wrong,
and it's just constantly.
Well, we would see a DNS lookup of a timeout here potentially in that case. That's right. And I said before that the network is always to blame for things. The next thing to look at usually is DNS. DNS is often always to blame, but in this case, thankfully, we're okay.
Yeah.
Right. Now though is where it gets interesting. So TCP connect, which is what I showed earlier with three-way handshake, that has jumped from 23 milliseconds all the way up to 3 seconds, which is quite a large jump. SSL not in play here because I'm accessing this application of a raw HTTP, but if that was causing an issue, you would see it. And then HTTP latency. So how long has the web server taken to respond? Which in this case, it would point me to the server being the problem. Something is wrong. Everything up to that point was green, as you saw with my quite simple traffic light system.
Yeah.
And now I know where I could potentially punt this issue off to. And the great thing here is that, having this visibility up front means that potentially the service desk can solve this before it even gets to the network guy. Because if you train them on this well enough, they're good enough to know that, well, it's not the network here. I can see it's the server. And it avoids the network potentially team straight up, which is also useful.
So the script that you ran adds a delay to the TCP response?
It adds a network delay to the entire server.
Right, and that's why we're seeing
which is a little artificial, and that may not be how it actually plays out. So in a real scenario, let's say it was a web server, pinging the web server, network response to the web
Even
server
TCP Connect would be low too.
Would potentially, but then if there's a database required for some way that
dependent
web page
services and things,
then we would see like a pretty large uptick in probably HTTP.
Yeah,
latency.
so you'd see TCP Connect, the one on top
All
here,
fine, all
would
fine.
be nice and low, and then there'll be spikes in the HTTP latency piece, which tells you even more.
It's even more that it's even further probably embedded in HTTP, not the server maybe running out of resources or something like that.
Interesting.
So really useful. And just to show another example, but again, here's one we prepared earlier. I'll flick the time range back to 3 hours ago. Something that I also did, which this laptop's quite powerful, so it didn't really result in much of a user experience degradation. I maxed out the CPU on my laptop because that is also potentially a cause for a user experience issue. We had a customer the other day. We are doing a proof of concept with Prisma Access at the moment. They were saying that things were slow. We jumped on their machine. We looked at ADEM. We could see that the CPU on the device was up at 100%, and that's because they left a screen recording software on without realizing. Maxing out the CPU, impacting user experience.
Can you find out what the actual process is?
That is a good question. Let's have a quick look. We can do this on the fly.
That's a deep...
here we go. So top 5 processors consuming... Yeah,
wow.
so we could. There you go. I didn't even know we did that.
Oh. What is Loom? That's a game from 1998.
No, I think it's a screen capture
1994.
software now. I don't actually know for sure.
That's right.
But yeah, like if you were
of course Chrome.
Oh, there you go. There you go. Shout out to my boss. That you can see right where the issue potentially could be, and you've got a much better idea of it's this process. So yeah.
Oh, I noticed there's some more under device health metrics. We've got some more tick boxes.
That's right. So memory, you called out with RAM, spot on. CPU, we've already discussed, but battery also can contribute because when battery starts to go low, it can start to wind down, or what did you say?
Switches into power saving mode.
Undervolt or underclock.
Underclocking.
Right, which means you've got less power available to you, which if it's an application that might be a little on the process intensive side, then it's going to hit the machine and the user.
So I do a bit of video editing. It doesn't work on battery, not on this anyway.
No, it needs a fair bit of grunt. Yeah, exactly.
Yeah, awesome.
So there you go. Like that from a network person or service desk person is gold. And from a day-to-day standpoint, where, as we mentioned, users aren't really in the office anymore, they could be anywhere. This can be the difference between solving a user experience problem quite quickly or it dragging out and having, someone complain. And maybe someone you don't want to complain. There's always noisy users or senior people that like to make noise when things don't go so well, and you want to be able to find that quick.
So one thing you mentioned is being proactive as well before people complain.
Yep.
So this, and if you scroll back to the top, this tenant might not have it, but something that I talk about in our 318, the Prisma Access class, is that you can drill down. So you can see how are all of my users, what's all my user experience, kind of what we said before.
Yep.
And then it'll say, oh, we've got a group of users who
have an issue with an ISP or something.
So you can see it across the whole environment. You could drill down just to one app.
Yep.
You could drill down to like locations and things like that as well, right? So you say, how my Australian team going, Indian team, Singapore team, whatever.
Yeah.
And you can really just jump down and get as granular, deep as you want to a per user point.
Before they even complain.
Yeah.
As you said, right? So you could trend, like if you had a very key app within your business that was key to that business running and making money, you would potentially focus a lot of time on that. You might have it as a dashboard in your service desk up on a screen, that if you start to see a drop across a large user base, you could get ahead of that before the people or the users hopefully even noticed.
Can you generate alerts?
With thresholds?
Yeah, so it's not just on the screen. It's like, oh, hey, Luke, you should look up at the screen kind of thing.
You've stuck me there. I don't actually know. I would hope so, but we can maybe put a comment or something like that to check. But yeah, that would be useful, right?
I think because that's next level. Then we're like,
that's right.
You as an analyst, I say, you as an admin or help desk or whatever your role is, you don't have to watch that.
No, you just get an alert. There is also something that I haven't even discussed yet. There's also a self-serve aspect of ADEM as well.
I've seen that.
So if it's something that is, I would say, local to the user's machine that they have control over, potentially to fix, such as Wi-Fi, such as battery, CPU, the Global Protect client can prompt the user to say, hey, we've noticed that CPU or something is high. This may be impacting user experience. So they can self-serve and fix the issue again before even logging something. So that's another part of the solution that I don't have unfortunately set up here in the demo. But
I've seen that. You're right. It's like basically like if you were sitting next to the microwave and it's lunchtime and
it wouldn't tell you it was a microwave, but
it won't. But it'll be like, hey, did you know your Wi-Fi is poor performing?
Yeah,
that doesn't, you know what I mean? Is currently not performing so well.
Exactly. And the user knows, they fix it. Happy days.
You'll be like, ding.
Yep.
Oh, it's back.
Super useful. Yeah.
Not super useful, as in like microwave's done.
No, well, yeah, true.
All right. Well, that's really cool. Anything else? I don't know if there's anything else we want to jump into on that.
No, look, that's pretty much it. Hopefully that was quite revealing in terms of the way that things actually happen in the real world with an app slowing down.
There is one more thing. One more thing that we can look at.
Okay.
I've seen that when we're looking at these pathways just below, that you can really get granular into the hops. Path visualization. There it is.
Spot on. So think of this like a trace route kind of on steroids. So if you were wanting to look at the network hops that are along the way between, again, a user and an app, you can get some visibility of that as well. And you can also see where potentially there might be something that's slow.
So that's like on a per hop basis. It will go yellow if that's the...
If there's a higher response time in a particular hop, and that might be in someone's local network, it could be somewhere on the internet. If it was an ISP that you had control over, it's like, your
if you are the ISP.
Yeah, if you are the ISP, you would see the particular hop along the way that was contributing to a potential network problem. In this case, everything's pretty healthy. We can see the little orange guy over here, which is saying it's actually probably the device from a CPU standpoint.
Right.
But we get all these sorts of useful information around, hop by hop information, which again is just like trace route, which you don't normally have access to unless you're on the user's machine at the time of the issue.
Which we often aren't.
No, exactly.
So if someone wanted to explore this in more depth, I know that we have like obviously yourself and people can get involved, but like what's an avenue? Like if you're a Prisma Access customer and you're like, I want
to try this out.
Yeah.
Talk to your account team, your account manager or your SE, and they can enable a trial very, very quickly. I think it's something like 30 days. They can walk you through the basics of getting things set up and you can start to experience it for yourself. That's the best way to get your hand.
Now you mentioned all of this is collected as a courtesy of part of the Global Protect agent.
Yep.
So that's the whole mobile user piece in Prisma Access.
Correct.
So obviously you can't use this unless you have Global Protect.
That is true. Now, that may change later, but for now you do require Prisma Access and the Global Protect client. Okay. You can also get these synthetics from, these metrics from our Prisma SD-WAN solution as well. So in that scenario, it's the SD-WAN device that's doing those tests, so we can get a branch-wide view of how a user is experiencing something. Right. And you can combine that with even the user at the site as well to see, again, the entire chain. If there's something wrong with the SD-WAN device.
And that would mean, because this is only available on Windows and Mac, correct?
Yes, from a client, mobile user at home or something, yes.
But the option you just mentioned, the SD-WAN solution, means that if people had their phones and iPads and things
in the office, we had an SD-WAN device, yes, we would see that.
Obviously, you wouldn't see the same depth. Like you couldn't see CPU, you see
not on the phone. No, but you would see branch-wide issues, which as an IT team you would want to know about pretty quickly.
Oh, that's awesome. All right, so speaking of good questions, we had a question come in from Jonathan Cardenas around ADEM licensing. So his question is, if I have 1,000 mobile user licenses, so that's people connecting through Global Protect to Prisma Access, do I need to match the license count for ADEM? So do I need to, if I've got 1,000 users, do all of them need to have
1,000 as well?
Yeah.
How does that work? I mean, ideally you would, because you want to track all your users, but some ways you can be smart about it is in every organization, there's always executives who probably complain or make the most noise when things go wrong, or you just have general users that, again, every business has that always seems to have user experience problems. So while you may have 1,000 users from a Prisma Access licensing standpoint, you could drop your ADEM licensing down to something like 200. So you just focus on where you get the most noise from, which is kind of a nice compromise and might get you more value. So yeah, that is something we see that's quite commonly done from customers. But again, ideally you'd want it for all, but you don't have to answer Jonathan's question.
Yeah, of course. Awesome. So Jonathan, thanks for sending that through. We are going to send some swag your way, and that opens it up to anyone else. So for those of you watching at home, I assume you're watching it at home, if you have any questions that you want answered in a future episode of Learning Happy Hour, there'll be a link in the description below to submit that question, and we'll pick one, hopefully, for a future episode. And if yours gets picked, we'll send you some swag, something cool as well in the mail. So one last thing before we wrap up totally. I spoke to you earlier about some hobbies and things that interest you.
Yes.
And we know, I know now that you're into golf, which is something that I am myself trying to learn. Like I've had a couple of lessons.
It's a tough sport to learn.
It's hard.
Frustrating.
For sure.
Yeah.
So I took the right approach. I started, but like I'm still super, super junior. But there's some people in our organization who I'm starting to golf with. You know who you are if you watch this video. But
who? Tell me, I want to play.
No. I need to before I head there and play with them again. I need to up my game. So one, I'm not embarrassing myself. Two, maybe I have a chance of actually
beating them.
Maybe.
That'd be nice.
Yeah, maybe.
Yep.
We'll start with not being embarrassing. So
that's a good place to start from.
Yeah. So let's head down. There's a driving range nearby.
Albert Park driving range. Yeah, we can go straight there. Let's do it.
Let's hit up. Thanks for your work.
Thank you.
Let's go.
Let's go.
Play some fun. Have some fun. Cheers. Thanks.
Thank you.
We'll do the awkward intro thing because that's what you want to do,
okay.
right?
Surrounded by people, it's fine.
So how did you get into golf?
I was indoctrinated at a very young age. When I was about 4 years old, my dad taught me to do the basics.
Yeah.
I didn't really take it too seriously until much later in life. I still don't really now. With kids, golf's probably the worst sport for that because it's normally a 5 or 6 hour investment to play. Which
right.
You just don't get that anymore. So it's just more casual now.
Yeah, okay.
Hey, nothing wrong with that.
It's all
Take
right.
that on the course. It's good.
You reckon? Take it on a course?
Oh, it's straight.
It's
It's all about distance.
Not bad.
That's better.
That's really good. Won't be able to see it in video. Well, that lined very nicely. Wow. Is that in the bunker? No, past.
Can you hear that on there?
It's right next to the mic, I'm sure we can.
The $5,000 golf club.
It was.
You gonna go?
What special? Because I got some lessons.
Just don't try and bash it. Use your body. Your hands, passive. Don't let them do anything.
All right, I'll give it a shot.
So the ball should be approximately off your left heel.
That's set up.
Like generally along with the club, the closer to your front foot it's going to be.
Yep.
Wider stance,
Yep.
so you got a bit more of a base. And again, just relax, use your body. Your hands should come through last. Don't rush.
Wow. That's amazing. That was very well lined. I know it's a club. The club's a problem.
Those. I'm not doing it.
Yeah, I'm done. Retiring.
Hey, decent. Just a little bit high on the club face, but that was all right.
You know what we need? ADEM for golf swings.
I'll talk to our product team back in Melbourne.
That's the reason. Yeah. Isolate that with a packet capture.
この番組はご覧のスポンサーの提供でお送りします。
そうだったら僕の最後のギフト